Welcome to Nardar Academy. In this video, we are going to discuss area of plane regions. That is, we are going to find the area bounded by a curve using integration. Okay, here, suppose y equal to f of x is the given curve. See, this is the curve. Y equal to f of x, this is the given curve. And we are going to find what is the area bounded by this curve, x-axis, and these two lines, x equal to a and x equal to b. So, I have shaded the portion, no, how to find the area of this shaded portion. For that, the formula is a equal to, that is area equal to integral a to b f of x dx, otherwise y dx. Okay, that is equation of the curve. Integrate the equation of the curve from the limits a to b. That will give you area under the curve. Right? Okay, so simple formula. So what is the formula for area? Integral y dx. If the curve is given in the form of y equal to f of x. Suppose the curve is given in the form of x equal to f of y and we want to find the area bounded by this curve y-axis and the lines y equal to c and d. Simply you rotate this curve. Suppose if you have x equal to f of y here and this is y equal to c and this is y equal to d. Simple rotation of the curve. In that case, the area will be integral x into dy. Okay, either y dx, integral y dx or x dy. Both formulas will give you the area. Depending on the equation of the curve, you have to choose the formula. Okay, right. Let's do the problems. Find the area bounded by the ellipse x square by a square plus y square by b square equal to 1. See, this is the equation of the ellipse with major axis and minor axis given by a and b. That means this is the ellipse and this point is plus a and this point is plus b and here it is minus a and this is minus b. Isn't it? See, this is a symmetric figure. That is, if you fold this into four parts, fold with respect to y-axis and again fold with respect to x-axis, you will get a quadrant, you know. That quadrant, that is this quadrant, this first quadrant is there, no. If you find the area of this first quadrant and multiply it by 4, that will give you the total area of the ellipse. So, instead of finding the total area, I am going to find the area of OAB. Okay, only this first quadrant of area alone I'm going to find and I'm going to multiply it by 4. Okay, for symmetric figures you can do in that way. So area is equal to integral, what is the formula? Y dx. When you put y dx here, x is the variable of integration and you have to substitute the limits for x. See, from the equation of the ellipse, it is very well clear that here this point is a, isn't it? Here x square by a square. So this point will be a. That is from the properties of the equation of ellipse. Okay, x varies from 0 to a. Only in the first quadrant we are integrating. So 0 to a only I am taking. Right, y dx. So for this y, you have to derive this value of y from the equation of the ellipse. Okay, so here what is the equation of the ellipse? X square by a square plus y square by b square equal to 1. Isn't it? So from that y square by b square equal to 1 minus x square by a square. So y square equal to b square into 1 minus x square by a square, or simply y equal to plus or minus b by a root of a square minus x square. But since I am taking it in the first quadrant, it will be purely positive only. So I am going to substitute instead of this y, b by a root of a square minus x square into dx. That's all. Now b by a is a constant term which can be taken outside the integral sign. Root of a square minus x square. The integration formula is x by 2 root of a square minus x square plus a square by 2 into sine inverse of x by a. This is the integration formula. You have to memorize all the standard integration formulas for doing problems in this section. Okay. Within the limit 0 to a. First you have to apply the upper limit. No. If you apply the upper limit a, see this term a square minus a square will be 0. So the first term will become 0 for applying the upper limit. Second term a square by 2 into sine inverse of a by a. So sine inverse of 1. Okay, what about the lower limit? Here 0 into anything will be 0 and similarly sine inverse of 0. Sine inverse of 0 is what? 0 only, no? So lower limit, the entire term will become 0. So simply you are getting a square by 2 sine inverse of 1. When will you get 1 for sine function? For 90 degree, isn't it? So b by a square by 2 into pi by 2. So the answer is pi ab by 4. What is this? This is the area of 1/4 of the ellipse, isn't it? This is the area of the ellipse in the first quadrant. So for the complete ellipse area bounded by the complete ellipse, you have to multiply it by 4. So area of the ellipse is equal to pi into AB. Okay, right. Next. Find the area common to the circle x square plus y square equal to 4 and the ellipse x square plus 4y square equal to 9. So area bounded by one circle and one ellipse we have to find out. Okay, see, this is circle equation. How do you identify it is a circle equation? There are some properties of circle equation. First one is it must be second degree equation. That means x square y square, that should be the highest coefficient. Okay, highest highest variable powers, right? And then coefficient of x square and coefficient of y square should be the same for circle equation, right? Both the coefficients are equal to 1. And finally, product xy term should not be there for circle equation. So all these conditions are satisfied. So this is a circle equation, and actually the general form of circle equation is x minus a the whole square plus y minus b the whole square equal to r square. So here if you compare this with this equation, the center is a comma b here. So here the center is 0 comma 0, and radius here it is r square. No, r square equal to 4. So radius equal to 2. So this is a circle with center at origin and radius equal to 2 units. And what about this? This equation is also similar to this, but the difference is here coefficient of x square is 1, coefficient of y square is 4. That means both the coefficients are not equal, therefore it is not a circle equation. Okay, it is not a circle equation that we have arrived, and it is an ellipse equation because the standard form of ellipse equation in the previous problem only we have seen. No, that is the standard form of ellipse equation. So divide throughout by 9, because for ellipse equation right hand side you should get 1. That then only you can find the values of major axis and minor axis. Okay, right? So throughout divide by 9. So x square by 9 plus 4 y square by 9 equal to 1. So in order to find the major axis and the minor axis value, rewrite this equation. So x square by 3 square plus this can be written as y square by 3 by 2 the whole square equal to 1. So major axis is 3 and minor axis is what? 3 by 2. Okay, right? So this is the ellipse. I couldn't get the figure correctly, so adjust with my figure. So this is the ellipse and this is the circle. Okay, somewhere they cut here at this point. Okay, right? So under this is the shaded portion. No, this is the common portion, and that comes in all the 4 quadrants it will come. I have shaded only in the first quadrant. Again, this is going to be symmetrical shape. It will come in the all. It will come in the all the four quadrants. I am going to find the area only in the first quadrant and multiply it by 4. Okay, right? Now we want to find the area of this shaded portion. Only that shaded portion in the first quadrant is there. No, you consider that portion alone. This is the part of the circle and this is the part of the ellipse. And this is the point A where do they cut each other, right? Okay, the formula we have studied, no, that will give you area under the given curve. But here if you look at the shaded portion, here this part is coming under the ellipse curve and this part is coming under the circle curve. Understand? This part. So here at the point of intersection you have to divide the area into 2 portions. Okay. So this is the important point for these type of problems. When your area is bounded by 2 different curves, you have to separate them. Then only you can find the area. Okay. So here first part, at the point of intersection, just you drop a vertical line that will divide you into 2 portions. So this is the first part bounded by the ellipse and this is the second part bounded by the circle. Okay, right? So required area equal to 4 times area of first region and area of second region. For first region you have to find the value of y from the ellipse equation. For second region you have to find the value of y from the circle equation, right? Okay. Now that is clear. So for first portion find out y from the ellipse equation. For second portion find out y from the circle equation. That and all clear. What about the limits? The total limit is from 0 to 2, but here in between we have one point, no? So the first integral from 0 to this point and second integral from this point to 2. So for finding this point you have to find the coordinates of the point of intersection of the circle and the ellipse. So for that, take both the equations, x square plus 4y square equal to 9. Here x square plus y square equal to 4. Just you subtract them. What will happen? 3y square equal to 5. So y square equal to 5 by 3 or y equal to plus or minus root 5 by 3. but simply we are taking only in the first quadrant, so it will be plus root 5 by 3. Substitute the value of y in any one of the equation and you get x value as x equal to root of 7 by 3. So x equal to root 7 by 3 and y equal to root 5 by 3. That means this point is nothing but root of 7 by 3. Okay, so first integral is from 0 to root 7 by 3 and the second integral from root 7 by 3 to 2. Okay, clear? And for the first integral, get y from this equation. Y equal to what? 1 by 4. Okay, root of 1 by 4 into 9 minus x square. From this, y square is equal to 4 minus x square. So that I am going to substitute it here. So area equal to 4 times integral 0 to root 7 by 3 root of 9 minus x square by 4 dx plus integral root of 7 by 3 to 2 root of 4 minus x square into dx. Now this 1 by 4 which can be taken outside and this can be written as root 3 square minus x square and this can be written as root 2 square minus x square. So both the integrals are in the form root of a square minus x square. The formula already I have used in the previous problem, no, the same formula. So for this one, x by 2 into root of 9 minus x square plus 9 by 2, a square by 2, no, so 9 by 2 sin inverse of x by a within the limit 0 to root 7 by 3, the same formula here with a equal to 2. So x by 2 root of 4 minus x square plus 4 by 2, that is a square by 2 sin inverse of x by a, right? Limits on the root 7 by 3 to 2. Now you apply the limits. When you apply the upper limit, it will be 1 by 2, that is 1 by 2 into root 7 by 3 root of 9 minus 7 by 3 plus 9 by 2 sin inverse of root 7 by 3 into 1 by 3. Okay, and then for lower limit this will be 0 and this is also 0. And then you apply, you come to this term, upper limit 2, no, if you apply 4 minus 4 is 0. So first term will become 0. Here this will be 4 by 2 is 2 sin inverse of 1 minus here lower limit is 1 by 2 into root of 7 by 3 root of 4 minus 7 by 3 minus 2 sin inverse of 1 by 2 into root 7 by 3. Okay, let us do the simplification. So multiply this 1 by 2 inside. So 1 by 4 root 7 by 3 root 20 by 3 plus 9 by 4 sin inverse. I am multiplying this 1 by 2 inside. So it will be 9 by 4 sin inverse of root 7 by 3 root 3 plus here this will be pi by 2, no, sin inverse of 1. So 2 pi by 2 minus 1 by 2 root 7 by 3 root 5 by 3 minus 2 sin inverse of root 7 by 2 root 3. So this is nothing but 4 root 5, isn't it? Sorry, 4 into 5 which can be written as 2 root 5. So 2 root 35 by 3. Here this will be 3 minus 1 by 2. This term I have written again. 1 by 2 root 35 by 3 plus this is pi and sine terms I have combined together. So 9 by 4 sine inverse of root 7 by 3 root 3 minus 2 sine inverse of root 7 by 2 root 3. Okay, right. So finally the area is equal to, multiply this 4 inside. So what will you get? These two terms get cancelled. So 4 pi plus 9 sin inverse of root 7 by 3 root 3 minus 8 sin inverse of root 7 by 2 root 3. Beyond this the simplification is not possible. So I am leaving the problem here. Okay, next. Next problem. Show that the area enclosed between the parabola y square equal to 4a into x plus a and y square equal to minus 4a into x minus a is 16a square by 3. Okay, the two parabolas are given. We have to find the area in between them, right? Okay, now you see this is like y square equal to 4ax. So it will be open right side. Y square equal to 4ax means open right side. But here in the place of x you have x plus a. That means here this point, this vertex will be at a, minus a. Okay, so this is the curve, first curve, y square equal to 4a into x plus a. What is the second curve? Y square equal to, this is like minus 4ax. Right, so it will be open left side. Minus 4ax means open left side, but not x here, it is x minus a. That means the vertex will be at a. So this is the exact diagram of the given parabolas. In between area we have to find. So as usual in the previous problem, we are going to find area in the first quadrant and multiply it by 4. Okay, right. Now we have to find out this point clearly I know it is a, and this point we have to find out, no, this will be 2a only, but let me tell you how to find out. Okay, that is on this line value of x is 0, no, put x equal to 0 in the given equation. If you put x equal to 0, what will you get? Y square equal to 4a square. That means y equal to plus or minus 2a. That means the curves cut at y equal to plus 2a and minus 2a. This part is not required. Okay, because this portion is very clear, 0 to a only. This point only I want to find. For finding the intersection of the y-axis, you have to put x equal to what? 0. Okay, so the limits are clearly known. X varies from 0 to a and y varies from 0 to 2a. Now let us find the required area. Now you see, for finding the required area, right, actually see, it is, though it is symmetric, here the equation of the curve, here it is y square equal to minus 4a into x minus a. Here it is y square equal to 4a into x plus a. Therefore, I am going to find, in the first quadrant I am going to find it by using the second parabola equation. In the second quadrant I am going to find using the first parabola equation. So integral minus a to 0. From this equation, what is the value of y? 2 root a into root of x plus a dx, and for this problem it is 0 to a 2 root a into root of a minus x dx. Okay, now you integrate 4 root a integral minus a to 0 root x plus a dx plus 4 root a integral 0 to a root of a minus x dx. The whatever area you are getting here, that will be multiplied twice to find the entire area. Okay, right, this is root x plus a. Now what is the integration? X plus a power 3 by 2 by 3 by 2. Okay, and here it is root a minus x means what? A minus x the whole power 3 by 2 by 3 by 2 into minus 1, because it is a minus x, no, so 1 minus 1 will come here. Now you apply the limit. If you apply the upper limit, it will be simply a power 3 by 2. For lower limit, this term will be 0, and here upper limit value is 0, lower limit value is a power 3 by 2. So what I am getting? 16 a power 4 by 2 by 3, that is 16 a square by 3. Okay, right. Next problem. Show that the area of a loop of the curve y square equal to x square into 4 minus x square is 16 by 3. One loop of the curve we have to find. See, for finding the limits, you put y equal to 0. That is where y equal to 0 means where it cuts the x-axis. What will you get? 4 minus x square equal to 0, or simply x equal to 0. Okay, when you equate 4 minus x square equal to 0, you are getting x equal to plus or minus 2. That means x equal to 2 is the limit. So if x is equal to 0 implies y equal to 0. So the limits are from 0 to 2. Just you integrate y dx. X into root of 4 minus x square dx. Here the direct integration, instead of doing the direct integration, I am making use of substitution method. Directly also you can integrate by taking x square equal to t. Okay. Now I am going to take x equal to 2 sin theta. So this will be what? Root of 4 minus 4 sin square theta. And instead of dx, you have to substitute 2 cos theta d theta. And x equal to 0 means theta is also equal to 0. And x equal to 2 means theta equal to pi by 2. So integral 0 to pi by 2. 4 sin theta cos theta into 2 cos theta d theta. So sin theta into cos square theta d theta. This we can make use of either reduction formula or beta gamma integral. I am going to make use of beta gamma integral. That video already I have posted. It is there in the playlist. You can check that video also. So sin power m cos power n integral 0 to pi by 2 means the formula is gamma of m plus 1 by 2, gamma of n plus 1 by 2 and gamma of m plus n plus 2 by 2. M is the power of sin and n is the power of cos. This beta gamma integral formula can be used for fractional powers of sin and cos also. Whereas reduction formula readily available only for integral powers of sin and cos. This formula can be used even when the powers are fractions. Okay. So this is gamma of 1, this is gamma of 3 by 2 by 2 into gamma of 5 by 2. Gamma of 1 is 1, gamma of 3 by 2 is 1 by 2 gamma of 1 by 2 by 3 by 2 gamma of 3 by 2. Okay, so 1 by 2 into this value of gamma of 1 by 2 is root pi, and 3 by 2 into this again written as 1 by 2 root 1 by 2 gamma of 1 by 2. Again this is root pi get cancelled. So the final answer is 8 by 3. Okay, and area of one loop is 16 by 3. Why it is 16 by 3? See, here x varies from minus 2 to plus 2, no? So that means it will come in the both the loops, two loops, you know, that will come in the second quadrant also. That you have to multiply by 2. So it will be what? 16 by 3. Next one is find the area bounded by the parabola y square equal to 4ax and x square equal to 4ay. This is a very common problem which is frequently asked in any type of exams you face. See, y square equal to 4ax means open right side, x square equal to 4ay means open upward, isn't it? So this common area we have to find. Now let us find the limits. Okay, right? here see x square equal to 4a y, no, instead of y you substitute root 4ax. So 16a square into x power 4 equal to 16a square into 4ax. So x power 4 equal to 64a cube x. That means x equal to 0 or x cube equal to 4a cube. So x equal to 4a. That means they will cut at the point 4a. That is, this point is there, no? They are cutting at 4a. So here the point is 4a. So the limits are from 0 to 4a. Okay. So how do you find the limits? See, in between these two curves we have to find the area, no? Integral y dx means that will give the formula for area below this curve. So area below this curve minus area below this curve. Okay. If you subtract both the areas, you will get the shaded, that is in between area. So area below the curve, which is the uppermost curve, y square equal to 4ax. Area below the curve, y square equal to 4ax minus area below the curve, x square equal to 4ay. So integral 0 to 4a, both the limits are same, 0 to 4a only. Root 4ax minus x square by 4a dx. Just to integrate, so what you will get? 2 root a into integral root x dx minus 1 by 4a integral x square dx. So this will be x power 3 by 2 by 3 by 2. This is x cube by 3. Limit 0 to 4a. So if you apply the limits, I am getting it as 16a square by 3. Okay, that's all. Thank you. Don't forget to like this video and subscribe to my channel. Okay, thank you.